Yeah, we'll start right now. Yeah, welcome all to this week 4 live interactive session. So, in this session, mainly we are discussing about the questions related to KNN classification algorithm. And so, in this week, we have seen that uh, the KNN algorithm and how it works, right? And in the kernel algorithm, we have seen different distance formulas, matrix. We have seen also we have seen the uh, classification evaluation, how we can evaluate the classification algorithm or model, so that we can identify which model can give us a better performance in particular task in a certain application, right? So as we know that the Canaan process is very intuitive, which has an we need to select the nearest neighbors. That is a k number of nearest neighbors, and among those k number of nearest neighbors, we need to identify that, or we need to take the votes from which of the class has been most of the neighbors are included, right? So based on this highest number of occurrences in the neighboring nodes, neighboring nearest neighbors, then we have assigning the new point, which is an that is particular highest neighbor class node, right? Yeah, well, I think you have understand the concept of the Canaan in the lectures, which is explicitly explained by the doctor. So here we'll discuss the some related questions. Along with that question, we'll again recall, or will also address your doubts or any queries. I hope you guys understand while we discussing the questions. So the minor things or any confusion about the how we can calculate the equivalent distance, actually distance between the new point and the all of the training point, how we can calculate taking an any distance metric, which let's take as an Euclidean. So how we can incorporate Euclidean metric to calculate the distance between the each of the training point with respect to the new point, right? Yeah. Okay. So let's initiate the our problems and discuss about the each of the problems in details. Okay. Yeah. First, please read this question carefully and try to solve yourself first this question. And after some time, we'll solve together. I will solve this question again. Okay. Please read this question carefully and try to solve yourself firstly. Okay. Sorry. Thank you. Yeah. So here, so is there any response for this question? Anyone got the correct answer for this question? First, you have to try yourself. Okay. So if it is wrong answer, then that is also okay. But try yourself. Let's try to think how we can solve this question effectively. We know we have studied the conditional probability, right? Yeah, anyone has got the answer? Okay, yeah. Yeah, I will discuss this question, means discuss the solution of this question. So here, for the question 1 to 3, this has been given a simple Bayesian network. So Bayesian network, you can see the variable x, y, z, and w. They are interdependent. See, means the y is dependent on the x, and z is dependent on the x and y. W is dependent on the x, y, z. Right. Right. So influence of the x will be incident at the w as well. W, x, z, and y actually. Okay. The influence of the x and y will be incident on the z and w, right? Likewise, so that you can assume that this information is propagating. So x information is propagating to the x, xy information is propagating to the z, likewise to the w. Okay, so the Bayesian network is fully specified by the margin of probability, right, of the root of the node x. X is a root node, this is a root node, and the conditional probability has been provided for each of the subsequent nodes here, right? So here in question 1, it is asking that what is the probability of x is equal to y is equal to 0. So y is incident at the second position, which is and depends on the x, right? So we know that probability of y is equal to 0. When we will get the y is equal to 0? At one, that is one condition that we know that the probability of y is equal to 0 plus probability of y is equal to 1 is equal to 1. Right? So minus probability of y is equal to 1. So why I'm writing like this? So we will get to know in the subsequent explanation. Because we have y is equal to 1 probability, we can calculate by using this conditional probability. Because you can see in the probability y is equal to 1, given that 1, given that x is equal to 1, conditional probability of y is equal to 1 given that x is equal to, using these two terms, right? Here they have given the probability of y is equal to 1 with given that some x is equal to 1 and x is equal to 0. So based on that, we can calculate y is equal to 1. How we can calculate it that? So you can see the probability of y is equal to 1 is equal to probability of y is equal to 1 given that x is equal to 1 into probability of x is equal to 1, right? Plus probability of y is equal to 1 given that, because we need to calculate y is equal to 1, that's why we are taking the conditional probability of y is equal to 1 given that x is equal to 0 and 1, right? So x is equal to 0, then into probability of x is equal to 0. You might think that there is a note given the probability of x is equal to 0, but we can calculate. How we can calculate? You can, as we have calculated for probability of y is equal to 0, like this way. Because we have a given probability of x is equal to 1, this value we have, uh, the question has given, right? So we can put here the value and we can minus it from 1, and then we will get a probability of x is equal to 0, right? So here the probability of x is equal to y is equal to 1 and x is equal to 1, we will get as an point 40, right? Here it is mentioned into probability x is equal to 1. That means which is at point 60, sorry, point 60, plus probability of y is equal to 1 given that x is equal to 0. So that probability is 0.30, right, into probability of x is equal to 0. So how we are calculating x is equal to 0? Probability, that is 1 minus probability of x is equal to 1. That is 1 minus 0.60. That we will get as an 0.40, right? 60, right. So you can calculate this. After calculating this, how, which value we are getting, that is an point, point 36, right? So we got that then probability of y is equal to 1 is equal to 0.36. Okay. So we have to put this value into this above equation 1. So we will get probability of y is equal to, sorry, y is equal to 0, 1 minus 0.36. So we'll get 0.64, right? So option C is correct here. Yeah. Is there any doubt? Have you got the solution? How we can calculate the probability of uh, y is equal to 0 while giving the, while taking the condition marginal probability of the root node as well as the conditional probability of y. I hope you guys got it right. Is there any doubt in this question?
Sir, one doubt, sir.
Yeah, go ahead.
In that p y is equal to 0, you have assumed 1 minus p of y is equal to 1. You substituted in the final step.
So in which part? I'm not getting it. So here,
Uh, in the initial stage where while you started explaining, yeah,
right.
that part what you have underlined. So how you assumed that y of probability of y is equal to 0 is equal to 1 minus p of probability of y is equal to 1. How
Here,
that?
so here, all the possibility, all the probabilities are getting for
That
the,
is an assumption or how?
no, no, you can see here that whatever the conditional probability or the marginal probability you are getting here, only the classes for the 1 and 0 here, right? So you can
Okay.
see, yeah, you can see in the probability of here in the conditional probability, the x has been taken as an x is equal to 1 and x is equal to 0.
Yeah.
Only the values is varying in between the, only the classes are 0 and 1, right? So
Okay.
considering this, we have calculated the probability of x y is equal to 0.
Okay.
Yeah.
Okay, sir. Okay, sir. Got it.
Yeah. So yeah, is there any another doubts or any confusion? Okay. So I hope whatever values we have considered right now you understood, right? So here only the classes are uh, 0 and 1, right? So considering this, let's solve the next question. Okay. Here we have calculated the probability of y is equal to 0 that we got as an 0.64. Okay. So let's you will start, you try to solve this question. Okay. So you might be understood right now. So which of them, which classes we need to take, and considering that how we can calculate the probability, marginal probability and the conditional probability. Yeah. So take some time and try to solve this question. Please let me know what would be the your calculated answer. There is no issue if it is wrong or correct. If it is wrong, okay. Yeah, anyone has got the answer? Sorry. Sorry, yeah. Sorry, I'm not. I'm on mute. Okay, I will discuss it again. So, anyone has got the answer? Okay, let it be. Yeah. We'll discuss this question here. So, previously, the question is asked about the marginal probability of y is equal to 0, right? At this stage. So, the question 2 is related to this node. Okay. So, you can see the probability of z equal to 1, given that y is equal to 1 and 0, that condition of probability has been provided. Right? But the question is asking about probability of z is equal to 1, but given that x is equal to 1, right? X is equal to 1. What is the probability of z is equal to 1 given that x is equal to 1, right? Right now, the probability has provided along with the x values, x given values, right? We need to calculate the values of conditional probability of z equal to 1 given that x values. So how we can calculate it, right? So here, considering one by one steps here. So the z is equal to 1 given that x is equal to 1. What we have, they have provided the probability of z equal to 1 with different values of y. Okay, so that we can consider because that provides the z is equal to 1 value, right? Z is equal to 1 value given that y is equal to 1. So we require the x factor as well here, the x variable. So we need to calculate probability of, sorry, probability of y is equal to 1 given that x is equal to 1. Are you getting? So here we have considered the first part, that is n z is equal to 1 given that x1 is equal to given that x is equal to 1, y is equal to 1. So let's multiply with probability of y is equal to 1. We have a y is equal to 1 given that x is equal to 1. Are you getting? Right. This is the first part we are getting for the y is equal to 1 combination. Right. Plus probability of z is equal to 1 given that y is equal to 0 for the another condition, another y is equal to 0. So at this point as well, we need to consider the probability of y is equal to 0 given that x is equal to 1. Right? Understood. So consider this, we will get a probability of z is equal to 1 given that x is equal to 1. This is an chain rule, right? This is an dependent probability we are calculating, that z is equal to 1 and y is equal to 1. At that point, y is equal probability of y is equal to 1 given that x is equal to, what is the probabilities that we are combining here, right? Considering here. So same for the y is equal to 0 1, y is equal to 0 probability given that x is equal to 1. Yeah. So here the values the question has provided for the this term is provided, this probability is provided, this is also provided, this is not provided. So let's see how we can calculate the same thing in the previous question we have applied. So same we can apply here. So probability of z is equal to 1 given that y is equal to 1, it is at 0.25 into probability of y is equal to 1 uh, uh, given that x is equal to 1. So that probability is 0.40, right? 0.40. So this is the first term we have written here. Another thing, that is an z is equal to 1 given that y is equal to 0, that is also provided here, right? So that is at 0.60, right? 0.60 into, so this probability how we can calculate. So you can see here the probability of y is equal to 1 x is equal to 1 has been given, that is in 0.40. So the same rule that we have to apply. So when the the rule v is that y is equal to 1 given that x is equal to 1 is plus probability of y is equal to 1 given that x is equal to, sorry, right. So probability of y is equal to 0 given that x is equal to 1. So it is equal to 1, right? Because we are taking the probability of the first class and the second class. So the two classes are there. So they're both addition of the two probabilities and 1, right? So we'll move this to this and it gets minus, right? So we have a uh, sorry, we this probability we need to calculate, right? This probability goes to this side, that is an 0.40 goes to this side, 1 minus 0.40 which is an 0.60, we are getting this value, right? So calculate this value, how much value we will get, we are getting. Mhm. That is the answer, that is our answer actually. How much value? 0.6. It's about 0.46, right? So option C is correct here. Yeah. Is there any doubt here? I hope you guys understood, right? So only the missing value here, that is a probability of y is equal to 0 given that x is equal to 1. So but there another part has been provided, that is an y is equal to 1 given that x is equal to 1, that is in 0.40, that we have minus by the 1, and then we are getting as in probability of y is equal to 0 given that x is equal to 1. Okay. Yeah. I hope you guys understood, right? Okay, let's move to the another question, which is related to this table. You may write this question, or I will also provide the this written document in the study material, in the extra material. Yeah, I hope you guys understood. Okay, is there any
Sir,
doubt, any questions?
sir, probability, like how you have written this? Can you just re-explain once again?
Yeah, sure.
That
Sorry, you are saying something.
yeah, like how you have made probability you have like you have written here. I'm not able to get that. Calculation part is okay, but um,
So this term,
ex-
this term is not you are getting.
yeah, yeah, exactly. The first, like how you have
This term was
started with the, yeah, that is okay, sir. That I understood. This part, like P of probability of Z is equal to 1, given that X is 1, and you have written this equation, that part.
okay. Yeah. So yeah, let me explain it again, so that maybe you will understand.
Yes, sir.
I think I will erase this. Okay. So here you can see the probability is asked about the z given that x is equal to 1.
Yes,
But
sir.
x is propagating from the y. Right?
Yeah.
So the probability related to the z and the y, it is provided here.
Yes, sir.
Here direct connection with the y. But
Mm.
probability of the x, how we will get? So how we will get from the y values, right?
Okay.
So you
Yeah.
can see, we are propagating information from x to y firstly, and y to z. So the y is entry point for this z. So how we will
Mm.
access this x, that is using the y,
Yeah.
right? So same concept we will apply while getting the condition of probability. So z is equal to 1 given that x is equal to 1. So the z probability of z is equal to 1, but given that y, that we can calculate easily, because that is an nearest neighbor, that is an previous node of the z, that is direct connected to the z value. So
Mm.
that we can consider z is equal to 1 given that y is equal to, let's take as an 1. Okay. So by we have y vector, right? Considering this y variable, let's access the probability of x. So at the time of the y is equal to 1, given that I require a probability of x is equal to 1, right? Like
Mm.
this. So this is for the possibility for the zero class, one class, right? So same
Okay.
for the zeroth class. Z is equal to 1, given that y is equal to 0, I need to access probability of, sorry, probability of y is equal to 0 given that x is equal to 1. Are you? So this is a summation actually.
Mm. Mm.
So yeah, have you understood, right? This is the
Yes.
part.
Yeah. Yeah. Yes, sir.
Okay. So then we need to put the values
Yeah.
simply, and
Yeah. That.
then we can calculate it. Right?
Yes, sir.
Yeah. Is there
Got it.
any, yeah, another doubts? Okay. So let's move ahead. Is the correct use? Yeah. So I hope you guys understood this question and the previous marginal probability question, how we can calculate the marginal probability and the conditional probability considering the subsequent their previous nodes condition. So considering that, can you please calculate for this probability of w is equal to 0 given that x is equal to 1? Also you have to consider this factor also, this concept, this equation as well, while you are calculating, because you can see here w is equal to 1 has been given, but w is equal to 0 is not given, right? So considering that, you can calculate it, right? So you have to access the Z, then Y, then X. The previous we have calculated up to this, we have calculated, right? Z given X, we have calculated in the previous question, so that you can use directly that value. That is upon 46, right? 46. I will write it again here. Probability. This we have calculated, right? Considering this, you will easily calculate the W value. Please try to solve, think how we can approach this question effectively. Yeah, is there anyone has got the answer? So anyone has got the answer? Okay, I will give some hint here. So, so how we can likewise the previous example we have solved, that is an probability of w is equal to 0 given that x is equal to 1. Consider the two things. We require the probability of w is equal to 0 as well as x is equal to 1. Considering the probability is equal to 0, how we can consider that is in probability is equal to w is equal to 0 given that z, that is in previous node, right? Right. So z is equal to 1, okay, into that. By using the z we need to access the x, okay, because x previous example we have calculated the x, right? By using z we will calculate the uh, what I'm doing, right? So here, right, so probability of z is equal to 1 given that x is equal to 1. Are you getting? So we are accessing the previous node because previous node data has been given, and by using the previous node we are accessing the x value here, and that x value we have already calculated in previous example, right? If that x value is not given, that related to the z, then we have to calculate it with the z, we have to access with the y using the x likewise. So here plus the probability of y is equal w is equal to 0, 0, then probability of w is equal to 0 given that z is equal to 0 into probability of z is equal to 0 given that x is equal to 0. Yeah, so this is an better enough. You are getting the hint. So by using this data you can calculate the values easily. So w is equal to 0 given that z is equal to 1. You might think that this value has been not given, but I previously has already mentioned that how we can calculate this value by using the probability of w is equal to 1 given that z is equal to 1. We need to subtract by from the 1, right? Then we will get probability of the probability of w is equal to 0 given that z is equal to 1. 0. Okay. Okay, let it be. I will put the values here. So the probability of w is equal to 0, z, given that z is equal to 1. So this term we need to consider, and which needs to minus by the 1. So we'll get as an 1 minus, that is an point 55, right? Into, right, 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 into z is equal to 1, and z is equal to 1, x is equal to 1. That value is previously calculated, which is n 0.46, right? To plus with the probability of z, w is equal to 0, z is equal to 0, then we have to subtract 1 minus from this value. That is, we will get as 0.70, right? Into this value has been also not given, right? Probability of z is equal to 0, x is equal to 0. Sorry, x is equal to 1 here, right? So that for z is equal to 1, this value has been given, right? We need to minus from 1, then we will get the probability for z is equal to 0 given that x is equal to 1, right? So that what could be the this value, that is at 0.54, right? So you can calculate this as an 0.56, which is about point 60, sorry, what am I, 0.63 we are getting this value. So everyone has got the answer. Is there any doubt in this solution? Yeah, I hope you guys understood. Okay. Yeah. So let's move to the another question then. So yeah. So please read this question. This is a very easy question related to the Canaan. So read this question carefully and please let me know which one, which could be the one correct answer. So for this, you don't require any calculation here. You can directly find. So the X which belongs to which class. So someone has given the answer which is C2. So please try other students as well. Let me know what answer you found. So this is very intuitive question. Ishka. Anyone has got the answer? So yes, many top students saying C2. Okay, the question again. Consider a binary classification problem. So it is mentioned that this is a binary classification problem, means it is an 0, 1, or and that is only two classes are there. Okay, with two classes C1 and C2. This is in class names, class 1, class 2. Class labels obtain other training set instances. Okay, train. So in the training set, 10 training instances has been given, and the instances sorted increasing order of their distance to an instance x is as follows. Okay, how will a k is equal to 5 nearest neighbor classify x? Maybe some students after reading this question might get confused, right? So I will show some visualization so that will be that will be easy to understand this question easy. So we have already training points, which are the 10 training points are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's assume this. Okay, so this is an 2D dimensional, the y and the x. Okay, understood. So this circle, sorry, this circle represents a training points here. These are the training points, training instances. We can say C2 instances. So the x has been given in this. It is plotted here. Uh, right. X is plotted here. I will take another color so might be easy to get understand. Okay, so the x, the this is an our new point which we have incident in this. So 1 second, some students are wanted to join. Yeah. So here this point we have to calculate the distance. So each of this point belongs to a certain class. Okay, that is C1, C2, C3. So we have calculated the distance, uh, training point calculated the distance between the x, the new point, and all other the training points, right? The training points, number of training points has been given as a number of tens. 10 points has been given. So we have calculated the distance between this and this, all of the points. Okay. After calculating the distance between all of the training point, so those are sorted, right? So sorted in order, that is an, let's take the nearest one is an, this one is an belongs to class 1. Okay, this one belongs to class 2. This one belongs to class C1. Okay, this one belongs to C2, 4, and this one belongs to class C2. This one means, uh, so I'm carefully observing that, because this set is given, which is an in, which one is, which point is an less distance, that point has a class below, that point belongs to C1 class. The second minimum distance point, it is an C2. So here this point represents first minimum distance point that we have considered here. The second minimum, which is an C2, that this point has been considered here. Okay, likewise this classes I have written here. Okay, the C1, C2. Okay, C1, C2, and belongs to C1. Okay, let it be. The all other the points are there. But here, after this introduction of the question, it is mentioned that actual question, which is an, how will a k is equal to 5 nearest neighbor classifier classify x? So that is the main goal of the k nearest neighbor, right? So after calculating the distance between the new x point to all other training point, this distance we have sorted, means all of the training points we have sorted based on their distance between their with the x values. So this is a sorted sequence has been given, that is in first neighbor, nearest neighbor which has belongs to C1 class. The second nearest neighbor class belongs to C2 class. Third nearest neighbor belongs to C1 class, right? Fourth nearest neighbor node or point, training point, belongs to C2 class. Fifth, like, so here they have mentioned k is equal to 5. That means we need to consider the first minimum shortest uh, distance nearest neighbors. These are the 5 nearest neighbors points are there. We need to find which class occurrences is higher, greater. So you can see the C1 is only 2, and C2 1, 2, 3. So C2 is equal to 3 occurrences. So C2 has a greater occurrence in the nearest neighbors. So that we are classifying this X node, X point, to a C2 class. That means option C is correct. C2 is correct. So I hope you guys understood. Is there any doubts or any questions? So all of you guys understood? If not, please let me know. I will explain it again. Hello, I'm audible? Okay, yeah. Yes, Palak, I will repeat it. So in the k nearest neighbor, what we are doing actually, right? So suppose we have, Okay. So let's take what in the k nearest neighbor we are doing actually. Firstly, whatever the training points we have, these are the attributes, attribute 1, attribute 2. Okay, so let's assume we have a table. This is attribute 1, attribute 2, and this is a class C1, C2, C3, likewise C2, because this is binary. This is object 1, object 2, object 3, object 4, likewise. Okay, so these are the training set, training set. So these points we are plotting on our two-dimensional plot, because we have only two attributes. If it is more than two, it is uh, plotted in a more dimensional, which is in third or fourth, so on. So considering this our question, we have 10 training points. Okay, so one, one, two, three, four, 5, and 6, 7, 8, 9, 10. Okay, and our new point, which is plotted at this position, on which basis it is plotted on that particular position, because that attribute values incident on this, attribute 2 value is at this point and attribute 1 value is at this point. Based on that, it is plotted here. So this is after plotting it, we have to calculate the distance between x to all other training points. Okay, that means we are calculating between this point, this point, this point, all other points. Okay, this is an x. Okay, after calculating the distance, we have to sort this, all the points, all the points based on the distances. So here, let's take assume that this is an O1, O2, object 1, object 2, object 3, object 4, object 5, object 6, object 7, object 8, object 9, and object 10. Okay. So after observing this, you can see object 4, these are the, so we have to sort this value. So how we can sort this value? So this is object 1 is a very shortest distance between the x point, object 10, then uh, object 7, object 5, and object 6, then object 1, likewise. Okay, so this is we have sorted based on the distance we have calculated from the x, the new point, right? So the here the points has been mentioned, it is an increasing order of the distance. So this, that means the object 4 is belongs to C1 class, object 2 belongs to C2 class, C2 class, object 3 object 7 belongs to C1 class, likewise C2, 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 C1, C2, C1, likewise. Okay, because the question has been given the instances sorted in a increasing order, so this is an increasing order, right? So this object 4 is a minimum distance greater than this object 4, this is a object 10 minimum distance. Okay, likewise. So these are the sorted objects along with their along with their classes, right? So here they have provided k is equal to 5. That means we need to choose the top 5 nearest neighbors which has lowest distance. Okay. So these are the initial 5 objects are the represented are the shortest distance from the x variable, right? So we have considered object 4, object 10, objects 7, object 5, object 6. These are the shortest, or we can say these are closely nearest neighbor from this x. Then we have to find the these objects belongs to which class, right? So that we have written here c1, c2, c1, c2, c2, right? Then we had to calculate occurrences of each class, how much c1 is incident in this 5 nearest neighbors, how much C2 incident or occurred in this five nearest neighbors, right? So you can see C1 is occurred in two times. C1, so we'll make it larger. C1, 1, 2, only two times. And C2, up to this, C2, 1, 2, 3, three times. So C2 is greater than C1, right? Among the five topmost nearest neighbor. Okay. So that's why we are assigning a label to X2, which is an C2 class. That's why the option C is correct. I hope you guys understood. This may vary as we have assumed. I'm not getting what we are not assumed here anything, because you can see this list of the classes of each of the object is been given by the question actually. So this C1 class, it is very nearest neighbor class actually. Then second nearest neighbor is an C2 class. Third nearest neighbor is an C1 class. Likewise, because you can see the instance sorted in increasing order of their distance to an instance X as follows. So this is an sorted increasing order list has been given, right? So based on this, we have only considered only five nearest neighbor, right? And among these five, which one is higher occurrence? Based on that, we have given. Understood? Okay. So yeah, is there any another doubts or any question? Okay, yeah. Let's move to the next question. Okay, this is also a simple question. Need to solve by the Euclidean distance. Right. Intuitively you can find it, but needs to solve by the calculating the Euclidean distance. It's related to the Cannon algorithm, Cannon classification model. So this is an training data has been given, right? This is an attribute 1, attribute 2, attribute 3, and the target classes. This is object 1, object 2, object 3, object 4, object 5, object 6 has been given. So considering this training data, you have to solve this question. K is equal to 3 has been given. Okay, so K is equal to 3 has been given here. And this one is our X new point. Okay, please read the question carefully and try to solve yourself. Let me know, is there any confusion in the question, or if you're not understood the question. Anyone has got the answer? Okay, for your reference, I will write a Euclidean distance C2. Yeah. Okay. Let's see which one is correct. Say and sub. So Euclidean distance for multidimensional is, suppose you are finding the distance between object 1 and x. Okay. So the Euclidean distance is in square root summation of I is equal to 1 to, here attributes are 3, so number of 3, then xi minus o1 I bracket square. So this is Euclidean distance formula for this question. So anyone has got the answer other than C2 or C2, C2 or C1? Only two options are, will get C1 or C2, or maybe there is a tie, not enough information. Okay, we'll solve this question right now. So first calculate the distance between the object 1 up to object 6. As previously in previous question we have discussed that we need to calculate the first distance between the new point x with the other all other the training points. So here the training points has been given object 1 to object 6. Okay, let's calculate for the distance between x to object 1. So write this, then let's 1 minus 0, 1 minus 0, 1, 1 square 1, plus summation we have to do 0 minus 0, 0, 0 square 0, 1 minus 1, 1 minus 1, 0, 0 square 0, so it is getting 1. Square root of 1, 1. Distance between x and O2, summation of means under root 1 minus 0, 1, 1 minus 0, 1, 1 bracket square 1, 1 minus 0, sorry, 0 minus 1, minus 1, minus 1 bracket square 1, plus 1 minus 0, 1 minus 0, 1, 1 bracket square 1, 3. 3 bracket square 3 under root, which is about 1.73. You can confirm it. Okay, it might be correct or not, I don't know. Distance between x to O3, O3, right, 0 minus 1, 1, 0 minus 0, 0, then sorry, okay, here we are discussing, right, that O3, right, O3, 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 1 minus 0, 1, 1 minus 1, 0 is equal to 1.4 something. Then distance from O4, this is plus O4, sorry, so I will write here maybe distance from x to O4, 1 minus 1, 0, 0 minus 0, 0, 0 minus 1, minus 1 bracket square 1, 1. So 1 the answer. So x from the object 5, object 5, 1 minus 1 0, 0 minus 1 minus 1 bracket square 1, 0 minus 1 1 bracket square 1, 1 plus 1, 2 under root 1.4, 1.4. So this is x object 6 under root 1 minus 1 0, 0 minus 1 minus 1 bracket square 1, 1 minus 1 0, it is getting 1. So let's sort it, the that is, and this is the first, right? So 1 it is in second, it is in third, it is in fourth, fifth, sixth. So object 1, right? Object 1, object 2, and object 3. Sorry, 3 not, this is an 3, we are getting that 1 values, 1 Euclidean distance. The objects are object 4, object 6, which are getting 1 distance, which is an less distance. So let's take their class it belongs. This C1 belongs, and this one belongs to C2, this one also C2. So correct option is a C2. So 2 C2 we are getting here, and 1 C1 we are getting. Yeah. Is there any doubts? Everyone has understood this question? Let me know any doubts or any question. Okay. If not, let's move to the another question. Okay. So please try for this. All the data is same. Also the k value is same. Only the x value is different. Calculate for this. Let me know which one is correct option. Anyone has got the answer? C1. Other than C1? Okay. So you can directly compare with the these objects. With that you can check that is an a1, where is a1 0, so 8 is also 0, a3 is 1, so which this one is a very near closest one. So this one is not closest one, this one close, likewise. So you can observing by observing also you can find, but that is not good habit, because if it is in suppose 100 or 1000 records, how we can do it, right? Manually doing it is a very difficult task. Currently we are calculating for sake of your understanding the equidistant distance, how equidistant distance works, get the closest nearest neighbor. Okay, yeah. So let's, I can try it here again. Object 1, 2, 3, 4, 5, object 6. So we need to calculate distance between x and object 1, which is an square root. 0 minus 0, 0, 0 minus 0, 0, 0 minus 1, minus 1, bracket square, 1. So we are getting 1. Right. Anyone has got, other than the Amitesh, anyone has got the answer? Distance from x to object 2, which is and the root. The root 0 minus 0, 0, 0 minus 1, 0 minus 1, minus 1, bracket square, 1, 1. Then 0 minus 0, 0 is equal to 1. Okay, distance from x to O3. 0 minus 0, 1 minus 1, 1 minus 0, 1, 1 is equal to 1.4 something. Then distance from x to object 4, which is an 1 minus 0, 1, 0 minus 0, 0 plus 0, right? It is getting 1. So this is in first part. Okay. So let's for the object 5, 6. Distance from x to objects 5 is equal to under root 1 minus 0, 1, bracket square, 1 minus 0, 1 plus 0 is equal to 2, 1.4. Distance from x to object 6, right? And then 1 minus 0, it is 1, 1 plus 1 plus 1, right? And it is 1.73 something. Okay, so let's sort it. Which one will get first? The one is a minimum value, right? So this one is a first, second rank, third rank, fourth, fifth, and sixth. If the k is equal to 3, so we have to choose what has been written. It is in 2. This one, object 1, right? Object 2 and object 4. So these three. These three are the three nearest neighbors. So let's check their occurrences of the classes. C1 1, C1 2, and C2 only 1. So it belongs to C1 class. So option B is correct here. Sorry. Option A is correct. It belongs to C1 class. I hope you guys understood, right? Is there any doubts? Or if you are not understood? Yes. Have you understood, guys? Okay, I hope you guys understood. Okay. Let's move to the, yes, someone is saying.
Yes, understood.
Yeah, okay. Thank you. Okay, let's move to the another question. Which one is this is a last question. This is a theoretical question. Might be we will get it correct. Okay. Read this question carefully and let me know which one is correct option. Anyone got the answer? You may take a guess actually. Here as well. Yeah. Yes. So yeah. So Meenakshi is saying that the option D is correct. What others are saying? That someone is saying A. Yeah. Here the high dimensionality data. High dimensional data means suppose you are taking more than the two dimensionals, what it impacts the Euclidean images, Euclidean, right? So, one second. So you may take values like 1 plus 1 or any values. Sorry, where is my pointer? Any take it is in high dimensional data. It is and less sensitive actually. The Euclidean images is not the proper way to get the distance between the new instance and the training point. Let's take as and let's suppose we have a 2 3 a point and b point which has an 4 5 like this way, right? So how we can calculate the distance between the a and b, right? A minus b bracket square with the summation of all attributes. These are the attribute, right? A1 and A2, right? So 2 minus 4 bracket square plus 3 minus 5 bracket square. So it is getting as an 4 plus 8. This is a minus 4 plus 4, which is about under root 8, near about, it says, and 2.8 something, right? So if it is fine, okay, you're not getting here what exactly the higher dimensional. Let's increase the dimensionality of the each of the variable. Let's take as in 2 3 0 0 0 0, right? E A 4 5 0 0 0. What do you think? While this for this dimensional data, what could be the answer? What could be the distance for this increasing dimensionality? It is getting as in same, that is in 2.8. It is also assumed that, well, because the distance between this point and this point is very low, right? But it is also considering that those are the far away, right? It is, and cumulatively it is discussing deciding that it is in all the points from the A on the B, it is in far away, right? So that is an one disadvantage. The for the high dimensional data, it may be, it is an some issue. It has an some issue from the Euclidean distance, right? So you can see the distance becomes less less reliable because every point seems far apart from this calculation, right? So can produce, second option is, and can produce counterintuitive results, right? So in this counterintuitive result, let's also take as an one example, maybe that will be easy to understand for the let's take two example sorry, let's take as in 3 points, okay? A B C, okay, and A point 1 1 1 and 1 1 1, And so the second point 1 2, and the another one we can take as, and which one value you can take as, let's take as an 9 9. Calculate the equivalent distance for the A and B only. So 1 minus 1, that is an 0, plus 1 minus 2, 1 minus 2 minus 1, that is an minus 1 bracket square 1, that is 1. Then B and C, the distance, sorry, A, let's take it A and C, the distance is an 1 minus 9, 8, right? 8 bracket square, and says minus 8, and plus and minus 8 bracket square, which will get near about the uh, 11 something, 11 something, okay, 11 3 2 something, okay, AC, right? Oh, so what we can do, we can increase the irrelevant data in this dimension, in these points. Sorry, in these points A, B, C. Okay. So let's take. So here I am writing a 1,000. B value is 1 2 1,000. C is equal to 9992. Okay, so we're calculating the A B distance, then we are getting the 0 1 plus 0, right? Still 1, we are getting still one value, because it is not also considering this, it is an 0 value, right? It is also 0 value, right? Only this value is large difference, but it is for this also it is showing as an 1. That is a problem here. So A and C, if you're calculating NC, here also you can see that 9 minus 8 square plus 8 square plus what we can say, the 99998, right? So it is near about 998. So it is an unrealistic large, right? So this shows that irrelevant dimensions can overshadow meaningful ones, right? Which makes a result counterintuitive. Okay. So that is the one problem here. Another is that as an in shrinking density space sparsification effect. So in this, let's imagine that we have 100 points which are evenly placed on a 1D line between 0 to 100. Okay, and each points that is evenly trained, this point average distance is and near about 1 unit is together. Okay, but if you place the same points in 100 dimensional space, right now we have discussed in the one dimension, right, 1D, in the single line, but the same points you have placed into a 100 dimensional space. You can see 100 axes are there, dimensions are there, they spread out so much, that's why the no point feels close anymore, right? Every point feels like there is a very far from that uh, the test point. So that example, like 1D, that is points are just on one line. They in 2D they split out on 2D dimension, and 100 dimension, the distance between them becomes so large that even the closest neighbor seems far away, right? Causing the sparsification effect here. Okay. So that's why the three options are correct, which are these are the issues to the Euclidean measures. So the option 4D is correct. Right. So in this session, this is the last one question. So in this session, we majorly discuss about the questions related to the Bayesian networks. How can identify or calculate uh, the probability considering the previous nodes, given that previous nodes is an with a particular value, right? Also, we have discussed the k near nearest near KNN related problems, and in that how we can choose the uh, how we can classify a new point based on the uh, training set shortest uh, training set shortest nearest neighbors objects, right? Also, we have discussed how we can calculate the Euclidean distance in between the x and all the training points, and based on this Euclidean distance, how we can classify the new points belongs to which class, right? Yeah, that's it for this week. If you, other than this, if you have any doubts, you can write me an mail. We'll discuss over there as well. In between, if you found any doubts or any questions, we can discuss over there as well. Okay. I hope whatever we have discussed here, you have understand. Yeah. Is there any doubts or any questions?
Not now.
Hello, sir.
Yeah. Yes.
Sir, in the third assignment, no, sir.
Yeah.
One question, we got the answer, but that answer is wrong. They have given and they have not given mark for that, sir. But we are getting only that answer. What to do for that?
In third assignment,
Yes,
you are
sir.
saying
Yes, sir.
which question, about which question?
Oh, sir, I don't remember the question number, all, sir. But the situation is like that. One question, we calculated and everything, and we got answer. And instead of that, sir, I will tell the question. 1 minute, wait, sir. Uh,
Okay. No problem. What you can do, I don't
uh,
have an access to that particular assignment. What you
uh,
can, in the SWAYAM, there is an one section that is an discussion section actually.
yes, sir.
And right in that, what you can do, you can screenshot that question or mention that particular question, and
Uh,
whatever solution you got,
uh,
whatever stepwise solution, you
okay,
can
sir.
attach that solution to that particular discussion and
Okay, sir.
post it there. Okay, so
Sir,
that considered by the that handling team, and
uh,
then will, if it is correct, then they will uh, modify it. If it is not, then they will
uh,
maybe mention. Okay.
sir, I will also mail to you, sir, that question. I will solve and mail to you. You can also check, sir.
Yeah, but whatever the decision has been taken by the uh, that uh, that team actually, that
Discussion, sir.
who has the access of that particular
Uh,
portal. Okay,
uh, so, so only.
has been done by another team. It's not in my hand.
Okay, sir. Sir, so in discussion forum, if we have to mention that, sir.
Yes, yes, yeah. You will
Oh,
definitely
that will be last week, no, sir.
that way. Sorry.
That will be in the eighth week, no, sir.
No, no,
Discussion
no,
forum.
no.
Uh,
Question 4N is available anytime. You can directly go to the announcements or in or QA.
uh, okay, sir. Okay, sir. So I can go to that URL and I can discuss that. Am
Right,
I right, sir?
right.
Okay, sir.
So
Okay, sir. Thank you,
whatever
sir.
the
Uh,
students may also respond over there. Okay.
uh, okay, sir. Okay, sir.
Hmm.
Understood, sir. Thank you, sir.
Yeah. Yeah, that's it. Okay. So this is enough for today. Yeah, you may leave this session. Thank you.